This video is about the volume and surface area of cones and pyramids, and I have grouped these shapes together because they basically have the same formula for the volume of their shapes. All of these pointy shapes, whether we're talking about a cone, whether we're talking about a square based pyramid or a triangular based pyramid, or any pyramid at all, any pointy shape where the top vertex is pointy, we can use this formula. So the volume is 1/3 of the area of the base times the height. Now obviously the area of the base changes depending on what shape it is. So in this case here the base is a circle. So the formula would be 1/3 times pi r squared, because that's how you work out the area of a circle, times the height. And when I say the height, I mean the perpendicular height. If it was a square-based pyramid, it would be 1/3 of the area of the square, which we know is just base times height, or base with length times width, if you like. So length times width, again multiplied by the perpendicular height. And if it's a triangle, we could use half base times height if it's a right angle, or half AB sine C if it's not a right angle. Anyway, so the point is, whenever we have one of these shapes, we just do 1/3 of the area of the base, whichever method we use to do it, times by the perpendicular height. So that's for the volume. The surface area, well, I'm not going to talk about the surface area of these shapes because that would just be adding up the area of the base, which is a square, so we know how to work that out, and then the area of the 4 triangles on each side, and we know how to work those out. Similarly over here, to work out the surface area of this shape, it would just be to work out the area of the triangle on the bottom, the triangle on the side, the triangle on the back, and the triangle on the front, and then adding those 4 triangles together. The surface area of the cone, well, we know that the face on the bottom here is a circle, so we know that that's pi r squared. The only extra formula you need to know is how we work out the area for the curved bit that wraps around that circle. So the formula for that is pi r L, so pi times the radius times L, and L is the slanted height there. And then that will tell you, so we do pi times the radius of the base times by the slanted length there. That tells you the surface area of the curved surface that wraps around, and then you would obviously have to add on the area of the circle underneath as well. So those are the formulae. Let's look at a couple of examples, 3 examples in fact. We're going to work out the volume of this pyramid to begin with. So volume is 1/3 of the area times the height. The area of the base here is just going to be 10 times 8, which is 80. The perpendicular height here is 6. So 1/3 times 80 times 6, or I could just do the 6 divided by 3 to give 2. So 80 times 2 is 160. Next example. I have been told here that the volume of this cone is 300 centimeters cubed. And I can see that the diameter of the base here is 10 centimeters. And I want to work out the height of the cone. So I'm going to start off by writing down the radius as being 5, because if the diameter is 10, then the radius is 5. And that's useful because I'm going to use that in the volume formula. So this is the volume formula. I've made it equal to 300. And in this case, the area of the base is pi r squared. So in this case, it's going to be pi times 5 squared. Now I'm just going to rearrange this to make x the subject. So I'm going to times both sides by 3 to get rid of that. And while I'm at it, pi times 5 squared is 25 pi. So the 300 became 900 because I times by 3. That's 25 pi. And then if I divide both sides by 25 pi, that will tell me the height, which is 11.5 centimeters. And the last example I'm going to do in this video. So here I have a cone. I can see that the diameter of the base here is 8 centimetres, and I can see that the height here is 3 centimetres, and I want to work out the exact surface area of the cylinder. So the surface area is going to be the area of the circle underneath plus the curved surface that wraps around it. The area of the circle is pi r squared. The area of the curved surface is pi rl. Now, if the diameter here is 8, then the radius is going to be 4. So I know this is going to be pi times 4 squared. So that's easy enough. This, however, is a little bit trickier because notice I've not been given L. I've been given the perpendicular height here. I haven't been given the L that I need. But if I know that this height here is 3, and I know that this is 4, hopefully you can work out what that's going to be. It's going to be 5. Because we've got a 3, 4, 5 right-angled triangle here. Basically, I've just done 3 squared plus 4 squared, square rooted, to get the 5. So we can do a bit of right-angle trigonometry, a bit of Pythagoras here to work out these missing sides if we need to. So pi times the radius, which was 4, times the length, the slanted length there, which is 5. We times them together, we get 20 pi. So 16 pi plus 20 pi is 36 pi, and that is the exact surface area. Just put the centimetre squared there.